Hello everyone, this is video number 3. Today we're going to talk about motion in one dimension, otherwise known as linear motion. This is the book that I'm following. You could use any book. All physics books are the same, just the illustrations, examples, and problems are all different, but physics hasn't changed much. So before we start talking about linear motion, I gotta tell you that I'm not gonna explain everything. You gotta have a professor, high school teacher, middle school teacher, whatever. They have to teach you the basics, because this is really meant for people that know a little bit of physics, or at least could follow what I'm gonna try to say, which is basically still the basic stuff, nothing new. It's not none of my equations that I developed that are in no physics book in the world. And if you're following me on YouTube, you're going to be one of the first people to ever see it. I really hope to win a Nobel Peace Prize. I just want to pay for my education. But anyways, let's move on. We got to talk about vectors and scalars and what's the difference. Scalars is something like, an example would be like temperature. Temperature would be a scalar. And a vector has magnitude and direction. For example, this is supposed to be a road and an intersection. It has a 60 degree. It's on First Street. I believe the other street's Park Street. You know, you could obviously just read vectors, 3 paths from your apartment, blah, blah, blah. So those are vectors and scalars. If you just gotta ask your professor to describe it to you, even though you'll probably learn about that in the first day. Well, anyways, linear motion. Well, why I was on the vectors for you is because if you look at a vector in my physics and in Newtonian physics, basically you have a mass, an acceleration, and an angle. Since we're talking about linear motion, I just put 180 degree as your line. So this is your prerequisite before we go to chapter 3. So anyways, moving on. This is the basics of how to solve any problem in physics. You divide it into x direction, which is your cosine, and your y direction. And if you want to get an angle, you take the tangent of both vectors after you simplified them and added them. For example, this is the cosine. Cosine I use as x, sine is y. So you take all your vectors and you line them up, and you basically start adding them together. So you get all the x vectors in the x directions, and you start adding them, and then you get your c. For sine, same thing. So if you know physics, this should not be anything strange for you. Otherwise, I highly recommend to go and get a physics book and start reading. So mass and acceleration is equal to force. So I forgot to tell you that. So a force actually has a vector in it. Well, a force is a mass and acceleration. So this is all forces. And vectors have magnitude and direction. So you use your tangent, you get your angle. And if you want to get your magnitude, for example, if you want to get your distance traveled, this is your equation, the square root, your x and your y's. So a force has to do with mass and acceleration. In one dimension, your mass and force, you don't really pay it. Well, I guess the best way to say is in one dimension, you kind of ignore it. The only thing that really matters is your acceleration, your velocity, your time, and the distances. So you get like a x1 and your x2 or whatever. If you're going in the y direction, it's y1, y2. So these are all equations for your acceleration. So remember, motion in a linear direction just deals with acceleration and all the acceleration equations. Some of these are actually 2 or 3 dimensional, but really it's mostly all just one dimensional. So these are the same equations as above. And then this is when you start getting your new equations. I forgot what this one was. It was in my paper. I just can't remember if I actually read it right. But either way, all these other ones are correct. So you got your Vx, velocity x, if you want to find your velocity at whatever time. And this is your initial velocity. And then here's another equation, your x, where you want to be at. Like if distance traveled. And then you get your starting point, your original velocity, your time. And it's all basically the same thing. Here's a y. Here's y, velocity y in the y direction, minus the gravity, the time. If you want to find a y distance, how high you went, y equals y naught. Y naught means your v naught is equal to your original velocity minus the 1/2 gravity times squared. So these are all just basic 1-degree motion equations. You should know them. You should know how to use them. For example, if you, in your problem, if you only get your x and the x naught, and they tell you, oh, solve for your whatever equation, and you really need it. So for example, if you want to combine this equation with this one, what you do is, or let's say even any of these, or even this one. So for example, you subtract the x to the other side, subtract the original placement of where you were to the other side. So you'll basically get x minus xo. Take the little pin. This is actually my Grand Canyon pin. Here's the letter H, because it's my favorite letter. Grand Canyon. I actually had this for years. I was actually can't even remember. I was in high school. I think I was either a freshman or a sophomore. Either way, as I was saying, you get your x, you subtract it to the other side. So you get this x, go to the other side. And then once you get x minus xo, you see how it's the same as over here. And let's say you want to get a velocity at a certain time. So you want to solve for this. So you plug in. So since this is your original, and then you get this equation right here, the rest of it, and you plug it in right here because it equals this. And then basically you solve all these problems the same, but remember, they all deal with acceleration. And remember, you must understand this before we move on to anything a lot harder. So remember, this is your prerequisite, and you should know this. This is basic, fundamental principles or equations of motion. They're very basic. High school kids use this, so I'm pretty sure if you're in the university, it shouldn't be much of a challenge for you. But once we move on to chapter 3, you're going to start seeing what I really mean by the master artist equations. They have to deal with the MA, the mass and accelerations, all the forces. And we're actually going to use, or we're going to solve equations using physics of the ancients, of the first pioneers of physics in the Western world. And you know, my professor, she was really good at demonstrating, and because of her, I was able to form my own physics, because there's Newtonian physics, there's Einstein physics, and now there's going to be a new physics in the market. Hopefully I could write a book. Hopefully someone wants to sponsor the book. Kind of make a really nice one like this, only it's not going to be as long, because what I have to tell you, really I could write it in 3 pages, but if you don't know any physics, it's really hard for me to talk to you. So this is the basic principles. Know them, do them, learn it. That's how the Army says. If you've ever seen in the Army now. But yeah, that's basically chapter 1. And then if you move on, let me go to the equations section of this book. Of the chapter, I mean. Yeah, as you can see, I basically did this whole book. Really, I'm going to combine Einstein's theory of general relativity, special relativity, combine them into my own method. Just a whole bunch of problems. You see, you just get what you know, plug it in, blah, blah, blah. It's nothing really special. So when you get a book, you should always do the problems on the book, especially if you own the book. Otherwise, do it in a separate piece of paper. See, the same equations I just showed you. Now it tells you everything what it means. The y naughts, the v naughts. See? Just use what you know. Plug it in, solve. Nothing really special. Show you how to monkey when it drops an apple. I just want to get to the equations really. I should have marked the page. Oh, there you go. See, these are the other equations, the velocity. It's basically the same thing. You just got to know how to use them. You just got to play with the equations. But remember, they all deal with the acceleration off a force, which is a mass, and an acceleration per area, usually. So remember, a force could also be like an engine. You have a mass, the engine's traveling at a certain acceleration or velocity. Acceleration, this is your basic acceleration equation, the v2 minus v1, or delta v over delta t, same thing. But yeah, well, basically chapter 2 is not that difficult, nothing new. You shouldn't be surprised of anything. But once I get to chapter 3, it's gonna really start the mastery artist equations, and it's the beginning. It's not the whole deal. Because once we get to work problems and momentum problems, you're gonna be like, I never seen these equations before. I know, because I developed it when I was taking my gen physics, and what happened is that the professor saw I was doing something new, and she wanted to know what I was doing. I never told her, but I'm gonna tell all you guys, and hopefully I could win a Nobel Peace Prize. So help me out, guys. Alright, well anyways, that's end of video number 3. So please follow me if you really want to know physics, or advanced physics, really. Well, have a great day, guys.